Welcome to section 2. We will have a quick look at the progress of classical computers. Thereafter, we will understand how various classes of data are represented and stored in classical computers and the quantum limitations faced by classical computers that propelled us towards building quantum computers. The initial computers during the 19th century, like the Charles Babbage difference engine developed in 1819, and the designs that followed the difference engine were mostly giant calculators. Z1 was first programmable computer in the world that used Boolean logic. It was powered by an electrical motor. All other parts were purely mechanical. The input and output were in decimal numbers, and the machinery would convert these to and from binary numbers. You could not load a program into the computer, but the computer was capable of executing instructions while reading from a punch tape reader. The program tape was 35 film with the instructions encoded in punched holes. Z1 was destroyed in a bombardment during World War II. A replica of Z1 is displayed at the German Museum of Technology in Berlin. The cathode ray tube or bronze tube was invented by the German physicist Carl Ferdinand Braun in 1897. The bronze tube is a vacuum tube that displays pictures when electron beams from an electron gun strike a luminous surface. The vacuum is essential in order to avoid collisions between the electrons and the gas molecules of the air. Collisions would slow down and leak the electrons. Without vacuum, the image on the screen would be less bright. The cathode here is just a material which, when heated, released electrons, and these electrons were directed using electric and magnetic fields to travel as a beam and hit the screen at specific spots. The fluorescent screen is made using coating of phosphor that, when bombarded with electron beams, converts the kinetic energy of the electrons into light radiation. Different compositions of phosphor produce different colors. The physics section discusses how this light radiation is produced. CRT was primarily used for display in televisions, computer monitors for quite a long period during the mid 1900s to even early 2000s. If you are about 20, it's likely that you might have seen this at your home or office. However, very few know that CRTs were also used as computer random access memory for a short period during mid 1900s. It worked on a similar principle as the CRT display, but slightly modified version of it. For the memory device, the electron beams were accelerated to have higher energy as compared to the display device. When the high energy beam hit the screen, it provided sufficient energy to struck out electron from the phosphor, thus creating a tiny positively charged dot on the screen. The struck out electron would eventually land somewhere on the border of this positive dot. The process of creating this positive charge well was used as the write operation in the computer memory, storing a single binary digit or bit which could be read by detectors capable of detecting electric field. A collection of dots or spaces, often one horizontal row on the display, represented a computer word. Increasing beam energy made the dots bigger and last longer, but required them to be further apart, since nearby dots would erase each other. The first transistor was developed in Bell Laboratories in the year 1947. It was constructed using germanium. Germanium is a semiconductor, and as we discussed in the physics section, the speciality of semiconductors is their conductivity can be controlled and manipulated. Transistors has been one of the most important inventions in history. A transistor can be used as an amplifier or a switch. In the following years, transistor went through many advancements. Silicon was used to make transistors as silicon was cheaper. The advent of transistors helped reduce the size of electronic computers. By 1960s, the use of transistors in computers became quite popular. The need for an integrated circuit was driven by the need to have smaller components and further reduce the size of electronic computers. The integrated circuit board allowed more information to be stored in a smaller area. Need for wires and many components was eliminated. Later on, the IC was built on silicon board. Fast forward to 2022, we have integrated circuits with 2.6 trillion transistors. The rate at which the transistor counts have increased generally follows Moore's law, which observed that transistor count doubles approximately every 2 years. MOSFET stands for metal oxide silicon field effect transistors. And as we discussed, they are electronic devices that are used to switch or amplify voltages in circuits. We talked about initial computers that were essentially just calculators. We looked at current complex integrated circuits which eliminate the need for excessive wiring and the need for multiple electronic components in the computer, thus reducing cost, minimizing the energy consumption, among many other advantages. We can store tons of data and programs on these circuits in binary format. The data could be documents, bills, data in these paper files, a dance or drama performance, conversations, music, pictures, numbers, so on and so forth. Watching movies, to booking tickets for an event, social media, online shopping, video conference, documentation, presentations like this one are few of the ways in which we utilize the power of having data on machines and being able to process this data as per business requirement. All of this data can be represented by numbers, and these numbers are stored and processed in binary form in the electronic hardware of the computer. Each key on the computer keyboard maps to a number. The binary form of this number represents the key press. This is known as the ASCII code. It used to be 7-bit. The 7-bit ASCII code had limitations. It did not have representation for non-English characters. It was then extended to 8 bits to support more characters. Later, Unicode was introduced in 1991 to represent all languages of the world. Unicode supports 4 bytes per character. Note that a bit is just 0 or 1. A byte is a group of 8 adjacent bits. There is a number corresponding to every key on the keyboard, not just the alphabets. Sound is an analog signal, meaning it varies continuously. To store it in computer, we need to convert it to a digital signal in the form of discrete numbers. Likewise, when we play an audio on computer, digital to analog conversion takes place. Sound is variation in pressure, which is converted to variation in current using principles of electromagnetism. Then to digitize it, the amplitude is sampled at regular time intervals, storing each value as a number. Sound quality is captured better by fine-tuning sampling rate, that is the number of sound samples taken per second, and the sampling resolution, which means the number of bits that are used for storing each sample. Image is represented as two-dimensional matrix of pixels, where each pixel is a tiny illuminated area on the display screen, made up of a combination of varying intensities of RGB colors, red, green, blue. To store images in computer, each pixel is represented as a number. Quality of an image can be fine-tuned by color depth, that is the number of bits used to represent each color. In a black and white image, there are only 2 colors. You could have an image that is made up of 24 colors or millions of colors, basically all possible combinations of RGB. An 8-bit color depth means each pixel can be one of 256 possible colors. And then image resolution can be improved by increasing the number of pixels that make up an image. When you capture an image, the image is captured as millions of tiny electrical charges. By using sensors, which each act as a pixel, sensors are made of an electronic component that is able to convert light into electricity. It's a photodiode. The tiny charges, which are the pixels, are then digitized by representing the level of brightness and color by numbers. Using binary number system simplifies storage, as we now need to represent only 2 states at hardware level. A switch on and off works. Transistors are used to create each bit. A mobile phone processor typically contains around 2 billion transistors. The switch on or off mode of transistors can be controlled using electrical signals. In most modern computing devices, a bit is usually represented by an electrical voltage or current pulse. For example, a 0 may be a voltage level below zero point 0.4 volt and a 1 may be any voltage level higher than 2.4 volts. In the memory cell shown here, a positive charge on the control gate attracts the electrons from the channel into the floating gate where they become trapped. The oxide layer that surrounds the floating gate keeps the electrons trapped whether or not the flash device has power, enabling persistent storage of data bits. Hence, the data is being stored by controlling the movement of electrons. Optical disks store data as bits and lands. Magnetic disks store data as tiny magnetized spots. There are two magnetic polarities, each one of which is used to represent either 0 or 1. The size of a silicon atom is zero point 0.2 nanometers. Suffice it to say, it would be impossible to create a silicon transistor smaller than that. We already have reached 3 nanometer size, which means each transistor is just few atoms wide. Smaller chips are complex to manufacture, but they are quite useful. As smaller chips use less power than bigger ones, the more transistors you can fit on a chip, the faster it is. It allows for providing processing power in handheld devices, mobile phones, smartwatches, etc. As we try to manufacture transistors smaller and smaller, we will soon reach a limit beyond which quantum effect starts to show up, and the circuit will no longer be able to hold charges to represent 1 or 0 reliably. Quantum tunneling limits the minimum size of devices used in microelectronics because electrons tunnel readily through insulating layers and transistors that are thinner than about 1 nanometer. If the electrons tunnel through, then we will no longer be able to hold the bit information.